Switzerland generates over $6 million annually exporting high-grade Oona Caviar, a luxury product retailing for up to $4,000 per kilogram. But make no mistake, this biological asset is not produced in a pristine natural lake. It is mass-produced using industrial wastewater draining directly from the Lötschberg Base Tunnel in Frutigen. To understand why this exists, we have to look at the accident that started it all. During the excavation of this 34-kilometer high-speed rail line, the third longest railway tunnel on Earth, boring machines breached a colossal geothermal aquifer deep within the Alps. The breach unleashed a torrent of water flowing at 100 liters per second. That is 86,000 tons of water flooding the infrastructure every single day. But the critical engineering problem was not the volume, it was the thermal energy. Due to the crushing depth of the rock, this water surfaces at a constant 20 degrees Celsius. This physical reality created an immediate legal deadlock. Discharging this geothermal flood into the local Kander River, a glacial stream floating near freezing point, would violate strict Swiss environmental laws. The resulting thermal shock would sterilize the riverbed and wipe out the native brown trout population instantly. Facing a multi-million-dollar construction bill for mechanical cooling towers just to waste this energy, the engineers chose a pragmatic alternative. They routed the hot runoff into massive concrete basins filled with 60,000 Siberian sturgeon. These fish are not just inventory. They are the system's primary cooling mechanism, absorbing the geothermal heat to fuel rapid metabolism before the cooled water is safely released into the wild. So, how do you build a farm inside a disaster zone? To harness this geothermal flood, engineers did not simply dig a pond. They constructed a $30 million industrial complex directly over the tunnel's north portal in Frutigen. The facility covers 35,000 square meters, roughly the size of 5 professional football fields, and acts as a massive parasitic organ attached to the Swiss railway network. The structural design is brilliant because it exploits a simple law of physics: gravity. Because the tunnel exit sits at an elevation of nearly 800 meters, the water flows down into the facility under its own hydraulic pressure. There are no massive intake pumps consuming electricity. The engineers effectively tapped a gravity-fed oil well of water that flows for free 24 hours a day. Let's break down the anatomy of this machine. The complex is divided into 3 distinct operational zones, creating a precise thermodynamic assembly line. Zone 1, the interceptor. Before the water sees daylight, it is captured by a specialized catchment system deep inside the mountain. It travels through 600 meters of insulated piping to maintain that critical 20-degree temperature. This is where the risk is highest. Since this water shares a drainage gutter with high-speed freight trains, it carries the constant threat of contamination from brake dust, hydraulic oil, or chemical spills. Zone 2, the production core. This is the heart of the machine. The water enters a massive indoor hall housing 40 concrete raceways and basins. This is not an aquarium. It is a high-density protein factory. The system operates on a flow-through basis, meaning the water is constantly replaced, keeping oxygen levels at saturation point without the need for expensive mechanical aerators. Zone 3, the fail-safe system. This is the most critical piece of engineering. To protect the 60,000 fish from a railway disaster, the facility is equipped with a military-grade sensor array. These sensors analyze the water chemistry in real time. If they detect even a trace of oil or chemicals from a train accident, massive steel valves slam shut instantly. The entire farm creates a hydraulic lock, isolating itself from the mountain and switching to internal recirculation batteries. They can survive for days without a drop of tunnel water, ensuring the multi-million-dollar inventory doesn't die in a catastrophe. Now that the hydraulic infrastructure is secured, the focus shifts to the biological engine inside the tanks. The choice of livestock here was not a culinary decision. It was a thermodynamic one. The engineers selected the Siberian sturgeon, Acipenser baerii. In the wild rivers of Russia and Kazakhstan, this species is built to survive brutal winters. But survival is not the same as growth. In its natural habitat, water temperatures drop near freezing for months at a time. During these periods, the sturgeon's metabolism effectively shuts down. They enter a state of dormancy, eating almost nothing and conserving energy just to stay alive. This natural pause is why wild sturgeon take anywhere from 10 to 12 years to reach sexual maturity and produce eggs. But inside the Lötschberg flow, winter never comes. The facility exploits the tunnel water to create a permanent, artificial summer. By maintaining a constant 20 degrees Celsius, the precise metabolic sweet spot for this species, the farm triggers a biological acceleration. The fish never go dormant. Their metabolic rate remains at peak efficiency 24 hours a day, 365 days a year. This thermal consistency cuts the maturation time down from a decade to just 6 to 8 years. From an investment perspective, this is a massive victory. It increases the capital turnover speed by nearly 40% compared to traditional outdoor farming. They are essentially hacking the biological clock of the species using waste heat. However, speed means nothing without quality control. Currently, the facility manages a biomass of approximately 60,000 fish, divided by age and size across the 40 raceways. The feeding protocol is strictly controlled by automated dispensers that calculate the precise feed conversion ratio, FCR. They use high-protein, sinking pellets designed to minimize waste. But the most distinct advantage of this system is the water chemistry itself. One of the biggest complaints about farmed freshwater fish is the muddy taste. This is caused by geosmin, a compound produced by cyanobacteria and algae found in stagnant ponds or earth-bottom lakes. The Tropenhaus sturgeon, however, are swimming in what is technically mineral water. The water has spent decades filtering through the granite massif of the Alps before entering the tunnel. It is pathogen-free and crystal clear, because the system operates on a flow-through model rather than a stagnant pond model. The water in the tanks is fully replaced constantly. There is no sediment buildup, no algae blooms, and therefore zero geosmin. The meat and eggs produced here have a clean, mineral profile that allows them to compete with wild-caught caviar, justifying the astronomical price tag. This clean environment also eliminates a major pharmaceutical cost. In high-density fish farming, disease is usually the enemy, often combated with heavy doses of antibiotics. But because the water source here is deep groundwater, physically isolated from surface pollutants and wild fish, the facility operates entirely antibiotic-free. The high flow rate flushes out ammonia and waste before bacteria can colonize, keeping the stock healthy through fluid dynamics rather than chemistry. As the fish reach maturity, the operation shifts from agriculture to medical-grade screening. Harvesting caviar is a high-stakes game. You cannot simply kill a fish and hope for the best. If you harvest a female too early, the eggs are too small and worthless. If you harvest too late, the eggs become overripe and mushy, ruining the texture. In the wild, you verify this by cutting the fish open. In Frutigen, they use high-resolution ultrasound technology. When a generation of females reaches the 6-year mark, the technicians begin a rigorous sorting process. Every single fish is netted and brought to a scanning station. Using a medical ultrasound probe, they scan the fish's abdomen to visualize the ovaries. This is not a binary yes or no check. The technicians are measuring the oocyte diameter egg size to the millimeter. They are looking for eggs that have reached the perfect maturation stage for Oona Caviar standards, typically over 2.4 millimeters. If the ultrasound shows the eggs are not ready, the fish is returned to the tank to grow for another 6 months. If the scan looks promising, they perform a biopsy. A small hollow needle is inserted to extract a few sample eggs. These samples are visually inspected for color, firmness, and membrane strength. Only, and strictly only, when a fish passes both the ultrasound and the biopsy is it cleared for the kill step. The processing phase is designed for speed and silence. Stress is the enemy of flavor. If a fish struggles or panics during harvest, its body releases cortisol and lactic acid. This breaks down the muscle tissue and sours the flavor of the roe. To prevent this, the sturgeon are stunned instantly using an electric current while still in the water. They are rendered unconscious before they are removed from the tank, ensuring the meat remains firm and the chemical profile of the eggs remains neutral. Once the fish is dispatched, the clock starts ticking. The extraction room operates like a surgical theater. The egg sacs, or ovaries, can weigh up to 15% of the fish's body weight. A 10-kilogram fish might yield over a kilogram of black gold. The eggs are separated from the membrane using a gentle sieving process, washed in cold water, and then subjected to the Malasol method. This is a traditional Russian technique meaning little salt. They add a precise amount of pure salt, typically less than 4% of the egg's weight. This is the only preservative used. There is no borax, no pasteurization, and no additives. Because the facility is land-based and integrated with the processing plant, the time from tank to tin is less than 45 minutes. This immediacy preserves the fresh, nutty nuance of the caviar that gets lost in complex international supply chains. But the caviar is only half the story. The remaining 90% of the fish, the meat, is not discarded. Sturgeon meat is dense, boneless, and structurally similar to swordfish or veal. It is filleted and smoked on site. By utilizing the entire animal, the facility creates a secondary revenue stream that subsidizes the operational costs of the caviar production. They have effectively engineered a zero-waste protein loop powered by a leaky train tunnel. The financial output of this system is just as engineered as the water flow. The final product, marketed under the brand Oona, is the first and only caviar produced entirely within Switzerland. Because of the Swiss-made label and the purity of the water source, the farm commands an ultra-premium price point. Their top-tier number 103 selection retails for roughly $4,500 per kilogram. The facility produces between 800 kilograms and 1.2 tons of caviar annually. Do the math, and you are looking at a revenue stream of nearly $5 million from the eggs alone. But who is buying tunnel-farmed fish eggs? They are not selling to supermarkets. The primary clients are top-tier Michelin-starred restaurants, luxury hotels in Gstaad and St. Moritz, and the first-class cabins of Swiss International Airlines. The selling point is the supply chain. Traditional caviar travels thousands of miles from China or Uruguay, requiring heavy salting and preservatives to survive the trip. Oona Caviar is delivered within 24 hours of harvest. Chefs describe the flavor as distinctively nutty and mossy, with a firm pop that only comes from extreme freshness. It lacks the muddy aftertaste of pond-raised fish because, chemically speaking, these fish spent their lives swimming in Evian. Is this model actually profitable, or is it just a science experiment? The answer lies in the operating expenses. In a standard recirculating aquaculture system in a cold climate, heating the water accounts for a massive chunk of the energy bill. You are fighting the weather every day. Here, the heating cost is zero. The energy is free, provided by the Earth's core. Furthermore, they utilize the entire animal. The 20 tons of sturgeon meat produced annually is smoked and sold as high-end fillets, generating a secondary income that covers most of the staff wages and fish feed costs. This means the revenue from the caviar is almost pure profit margin. The ultimate proof of this efficiency happened in May 2024. For years, the facility also ran a tropical house growing bananas and coffee using the waste heat. It was beautiful, but it was a financial failure. The revenue from tourists could not cover the maintenance. So they shut the garden down. They cut the flowers, but they kept the fish. This confirms the brutal logic of extreme agriculture. The sturgeon system is the only part of the project that survives the balance sheet. It is a lean, mean, protein-producing machine that turns geological waste into one of the most expensive foods on the planet. Despite the profits, this facility operates on a razor's edge. The very infrastructure that provides the free energy is also its greatest existential threat. The farm is geographically tied to the Lötschberg Base Tunnel. Cannot move. This means the entire $60 million inventory sits downstream from a high-speed freight corridor. While the sensors are advanced, a catastrophic derailment involving toxic chemical tankers inside the tunnel could overwhelm the filtration systems before the valves close. They are essentially farming inside the drainage pipe of heavy industry. There is also the biological risk. Siberian sturgeon are an invasive species in Western Europe. If a massive flood or structural failure washed these fish into the Kander River and down into the Rhine, they could outcompete native species and hybridize with local stock, causing an ecological disaster. The facility must maintain fortress-level biosecurity, not just to keep diseases out, but to keep the monsters in. So, is this just a Swiss anomaly, or is it the future? The implications extend far beyond caviar. Every major tunneling project on Earth, from the subway systems in New York to the mines of West Virginia, battles groundwater intrusion. We currently spend billions of dollars globally just to pump this water out and throw it away. Tropenhaus Frutigen proves that this waste is actually a geothermal gold mine. It demonstrates that with the right engineering, we can turn industrial byproducts into high-value protein, decoupling food production from the grid. It is a prototype for parasitic agriculture, farms that feed off the wasted energy of human infrastructure. Now, I want to hear from you. Is this the brilliance of Swiss engineering? Or does the idea of eating luxury food grown in tunnel wastewater turn your stomach? Would you pay $4,000 for railway caviar? Let me know your verdict in the comments below. If you want to see more deep dives into how engineers are hacking nature to feed the world, destroy that like button and subscribe to the channel. I'll see you in the next breakdown. Thank you for watching.